Hello, welcome to this video where we're doing case C of the types of discontinuities that exist in functions, and this is the last of the three videos that I've been doing in terms of this topic here. If you haven't watched the previous two, I encourage you to do so. Okay, so let's get into it. Removable discontinuity. By definition, removable discontinuity will exist for a function, suppose h of x at x equal to c, if limit as x approaches c of h of x is not equal to h of c. Well, that is entirely against the definition of continuity. We recall that there are three conditions of the continuity to be a reality or effect of the given function. Firstly, the functional value must exist at that point, the limit must also exist, and they must be equal to each other. So if they're not equal already, there is discontinuity at that point. Okay, and that is then the case when it comes to removable discontinuity. Graphically, how would it look like? If I have a parabola here, okay, Cartesian plane, and we can see that the limit on the left and the limit on the right will exist, but now there is a point here at C, sort of a point from the graph has been removed, right? And now f of c is not defined by the function here that is given, which is the parabola. It is a point that is in a different position, that is not actually lying on the curve itself. Okay, so that is an example of removable discontinuity. If I give you a linear function, okay, at that point we can see that the functional value is undefined. So we say here that is our h of x, right? At that point c, h of c is undefined. Okay, so here we have this now, limit as x approaching c, h of x is not equal to h of c. Definitely that is not equal to the same number as that one, which we'll get through the limit. Okay, so those are some graphical cases that can help you to spot or identify a removable discontinuity, and of course mathematically you can also prove it given the context and the information or details that comes with that particular question. Okay, so this takes care of removable discontinuity, and it takes care of the types of discontinuities that exist when we study calculus and the behavior of functions. And going forward, we are definitely going to merge continuity with differentiability of functions and see how those two guys links up, and it will lead us to much more interesting conversations and discussions. Okay, thank you for watching and stay tuned for more.